Alright, so continuing on with some rational expressions today. So in 6.2, we graphed rational functions. And if you remember the definition of a rational function, it was f of x is equal to p of x over q of x, where p of x and q of x were polynomial functions. So they were polynomial functions, and q of x could not equal 0. So a rational expression is basically, if we're talking about the difference between expression and functions, this right here is an expression, and then this right here is just the rational expression, but in function form. So that's pretty much what this definition of rational expression is. Rational expression is a fraction. So a fraction whose numerator and denominator are non-zero polynomials. So they are polynomials. So again, so just like up here, you have a fraction, polynomials on both the numerator and the denominator, but they are not 0. And a rational expression is in its most simplest form. So it's a simplified form of rational expression is when the numerator and denominator have no common factors other than 1. So other than plus or minus 1. Okay. So then you simplify a fraction whenever the numerator and the denominator have no common factors. And that's what simplifying fractions that's what we always do. We always make sure that the numerator and denominator are as simplified as possible. Okay? So the property of simplifying rational expressions is as follows. Okay? So given a times by c divided by b times by c, so this is a rational expression. Okay? I guess we should set some parameters though. So first of all, before we get into this, let's let a, b, and c be expressions with b not equal to 0 and c not equal to 0. So if this is the case, then if we take these expressions a times b, and if it's divided by b times c, then they have a common factor of c. So if they have a common factor of c, then to simplify, these cancel out from the numerator and denominator. So you divide out the common factor, and this would be equal to a divided by b. Okay, and we've been using this property all year long, pretty much without. It should just be like second nature to see these type of things in mathematics at this point. Okay, so let's look at this rational expression right here. So we have two polynomials on both the numerator and the denominator. Okay. Now we need to find common factors in both the numerator and denominator. So hopefully you guys are still pretty well versed in factoring. So we need to factor both the numerator and the denominator here. Okay, so on the numerator, this is a polynomial of degree 2, so it's a quadratic with a coefficient of 1. So because this is the case, we need to factor by finding, so factor x squared minus 4x minus 12, you need to find two numbers that multiply to be negative 12. So I'm going to find factors that multiply to be negative 12. And so that's going to be, but these factors also have to add to be negative 4. So I know 1 and 12, 2 and 6, 3 and 4, these are factors of 12. Now because it's negative, one of them has to be negative. But remember that these numbers, one of these pairs have to add to be negative 4. So I could achieve that through this pair right here with 6 equal to negative, with 6 being negative. So then what I do to factor this is I take two binomial factors and I can add in 2 and subtract 6. So this factored is equal to x plus 2 times by x minus 6. Okay, now to factor x squared minus 4, this is the same thing as x squared minus 2 squared, and so this is going to be the difference of squares, factored pattern. And the difference of squares says, if you guys need a reminder, it's a squared minus b squared is equal to a minus b times by a plus b. So in this case it's x minus 2 times by x plus 2. So that's how you factor these polynomials. So x minus 2 and x plus 2. So now that we have the factors, we can again use this property right here and cancel factors that are in common with the numerator and the denominator. So this has a x plus 2 factor in both the numerator and the denominator. So simplified, this would be x minus 6 over x minus 2. Okay. Now the original function right here is undefined. So the function is undefined whenever the denominator is 0. So this denominator would be undefined if x was equal to negative 2. So we have to make sure that we state that x cannot equal negative 2. That's a domain restriction. Okay. So we need to make sure that we understand that in this rational expression, x cannot equal negative 2. Okay? Alright. So here are some practice problems that you guys could go over. I can probably go over one or two, but so let's look at number 1. So for number 1, just factor what they have in common, okay? So the numerator, so this isn't a quadratic like we had up here. This is a quadratic with 3 terms, so this isn't the same thing. So there's just 2 terms, so just factor out what the 2 terms have in common. So I know that they both have a 2 and an x squared. And when you take those out, you're going to be left with x minus 4. So that's on the numerator. On the denominator, you have, it has a factor of 2, okay? And then, so it would just be 2 times by 3x squared. Now, the reason why I factor out the 2 is because I see that the numerator has a 2, so those would cancel. And then you can see that the x squares will cancel, so in the end you'll be left with x minus 4 divided by 3. And make sure that you note your domain restriction, which is x cannot be a value that makes the denominator 0, so in this case x cannot equal 0. Okay. Let's see. I'll go over this one. If you guys want to go over these yourselves, just to get an idea of how to do them, go for it. But in any case, so again, these are 2 different terms, so factor what they have in common. you can't factor out any numbers in common because 2 and 5 don't have anything in common except for 5 and 2, or except for 1, sorry. But you see how this has an x and this has an x squared, so you can at least take out an x from these two, from both of them. And then this one has a y cubed, this one has a y squared, so you can at least take out a y squared from both of them. When you do that, you're left with 5 times by y minus 2 times by x divided by x squared, y squared. Now I'm going to split this up just a little bit. X squared is the same thing as x times x and then y squared. So I do that because I notice I can cancel out these x's right here, and then I can cancel out the y squareds. So then this would just simplify to be 5y minus 2x over x. And just as the domain restriction, y and x cannot equal 0. So those are the variables. So x, y cannot equal 0. So this would be an example of quadratics that you have to factor using the method that we used up here. So to factor this numerator, I know that x squared minus 5x, so I need to find factors of 4 that multiply to be negative 5. So the only factors of 4 are 1 and 4 and 2 and 2. So it would have to be this one right here, and they'd both have to be negative, because negative 4 times negative 1 is going to be positive 4, but added together is going to be negative 5. So x minus 1 and x minus 4 divided by, and then here factors of 1 that add to be negative 2, that would just have to be x minus 1 times by x minus 1. And then you see that we have a factor of x minus 1 in common in both the numerator and the denominator. So you'll be left with x minus 1, x minus 4 divided by x minus 1. Okay. And so hopefully you guys can do this one on your own. But let's move on to this example 2. But before we get into that, let's make sure that we understand how. So now we're going to be multiplying rational expressions. So we just simplified, but now let's learn how we can multiply. So to multiply rational expressions, let A, B, C, and D be expressions with B not equal to 0 and D not equal to 0. Okay, and A divided by, so if this is the case, then this multiplication property, the property, is stated as A divided by B times by C divided by D. This is equivalent to just multiplying straight across, so you have A times by C over B times by D, and simplify if possible. Okay, so that's what we're going to do when we multiply. So here, in this example, we're given two rational expressions. We're just going to multiply straight across. So when we do that, we have 8 times by 7. I'm just going to leave it as 8 times by 7. I'm not going to actually multiply them together because I'm going to need to factor out common. I'm going to need to divide out common factors. So I'll just do 8 times by 7. And then times by, it should be x to the 7th times by y to the 4th. So because we're multiplying these right here, we're just going to add the exponent. So here's 3, here's 4, so that's 7. This has an exponent of 1 and 3, so we're going to add those to be 4. And then in the denominator, we have 2 times by 4. So this one I am going to multiply together because that's equal to 8. And I'm doing that because that means I have a common factor on the numerator and denominator. So I have 8 times by x times by y cubed, because y squared times by y is y cubed. So when I do this, well, first of all, before I start canceling things out, so I have 8 times by 7. So you see here I have some x's, so I'm going to take this x to the 7th and call it x times by x to the 6th power. And then this y fourth, I'm going to rewrite it as y cubed times by y. And then here I'm just going to leave at 8 times by x times by y cubed, because now I can cancel out the 8's, I can cancel out this x, and I can cancel out these y cubes. And when I do that, I'm left with 7 x to the 6th times by y, and nothing in the denominator. And then I just need to state that x cannot equal 0 and y cannot equal 0. Okay. And in this example, this one's just so in this example, notice that there weren't any binomials or trinomials, polynomials. These were all just individual monomials. So these are all monomials. So in this case right here, we have trinomials. So this is a trinomial right here, this is a binomial, this is a trinomial, this is a monomial. So we have different types of polynomials. Now, before I multiply, I am going to factor these. Okay? So I'm going to factor this part right here. So when I factor 3x minus 3x squared, they both have a 3x in common. So when I factor that out, I have 1 minus x. And then I'm going to factor x squared plus 4x minus 5. And I think we actually already factored something like that. Just kidding, we didn't. So, but anyways, I know that I need to find factors where these binomials here have numbers that multiply to be negative 5 but add to be positive 4. So that would have to be x plus 5 and x minus 1. Because 5 and negative 1 multiply to be negative 5, but add to be positive 4. So that's that factored. And then we're going to factor x squared plus x minus 20. So two numbers that multiply to be 20, negative 20, but add to be 1. So let's take factors of 20. We can do 1 and 20, 2 and 10, 4 and 5. So that's probably going to be our best bet. So we'd have to have positive 5 and negative 4. And then we were going to factor, I guess we can't factor 3x, we'll just leave it like that. But now that I know these factors, I'm going to rewrite this to be all the factors. So 3x times by 1 minus x over x plus 5 times by x minus 1. And this would be times by, and then we have x plus 5 times by x minus 4 over 3x. Now when we multiply these together, we can just multiply straight across, which really it's just like it's just going to be another big polynomial. So 3x times by 1 minus x times by x plus 5 times by x minus 4 divided by x plus 5 times by x minus 1 times by 3x. Okay, so let's see what we can cancel out. So on the top, notice that we have this 3x, and the bottom we have a 3x. And then we have the x plus 5 and an x plus 5. So if I write that out, I have 1 minus x times by x minus 4 over x minus 1. So you can see that these aren't quite the same, but they actually kind of are the same. So from here, I can factor out a negative 1. So this would be negative 1, and when I do that, this becomes x minus 1. Okay, so this is positive right here, but if I take out a negative, it makes the 1 negative. This is negative x, but if I factor out a negative, it makes it positive. So, and then x minus 4 divided by x minus 1. So here, we can cancel those out. So this would be equal to negative x plus 4, because I can multiply those together. And then nothing on the denominator. But if we go back to our original statement that we had, think about the domain restrictions from the original statement. Okay, so x cannot be any opposite. So if this is negative 5, then the denominator is 0. If this is positive 1, then the denominator is 0. And if this is 0, the denominator is also 0. So those are our domain restrictions. Our domain restrictions would be that x cannot equal negative 5, cannot equal 1, and cannot equal 0. So that would be the simplest form. Alright, let's do just one more example of multiplying rational expressions. So find the product of these two being multiplied together. Now, this is a rational expression, but this is not. But we can write it as a rational expression by saying that it's being divided by 1, because anything divided by 1 is itself. And so in this case, again, you can just use the property where you multiply straight across. But again, I'm going to factor first. Okay, so x plus 2 I can't factor, but x cubed minus 27 I can factor. So this is a property that I'm not sure if very many of you will remember, but it's the difference of cubes. And the difference of cubes was, well, we can go back to semester 1. SM3, I think that was in, let's see, 4 point, no, it would be 3.4 right here. So if you remember these factors, the difference of cubes is what we'd be looking at right here. So our question, our expression was x cubed minus 27, and 27 is the same thing as 3 cubed. So then if I were to use this, I would get x minus 3 times by x squared plus 3x plus 3 squared, which would be 9. Okay, so that's how we would get this expression. So x cubed minus 27. This this factored. So factor x cubed minus 27. This is x minus 3 times by x squared plus 3x plus 9. Okay, and then if we were to factor x squared plus 3x plus 9, it's a quadratic, so find two numbers that multiply to be 9 but add to be positive 3. So I actually don't think that there is No, okay, so no, it won't be factorable. You can't find those numbers, but that's perfect actually, because when I write this in factored form, so I get x plus 2 over, now we factored this out to be x minus 3 times by x squared plus 3x plus 9, and this is being multiplied by x squared plus 3x plus 9 over 1, and then when I multiply them together I get x plus 2 times by x squared plus 3x plus 9 divided by x minus 3 times by x squared plus 3x plus 9. So what that means is these will cancel because those are the same factors. So I'd be left with x plus 2 over x minus 3. And that would be its simplest form. Okay. Now there are some more problems on this last page right here, in these last couple pages, that have to deal with multiplication. So there's 5, 8, and 9. So if you want to go over those, go for it. But we're going to get into dividing rational expressions now. So this property right here, so let A, B, C, and D be expressions with B not equal to 0, C not equal to 0, and D not equal to 0. So here's the property of division, and it states that if you have A over B divided by C over D, this is equivalent to, so we've talked about this before, so we have A divided by B divided by C divided by D. So this is a case where you, if you guys, I've said it before, but I've always looked at this as the keep, change, flip rule. So you keep the first, change the sign, flip the second. So keep the first, change the sign, so A over B times by D over C, flip the second. These are equivalent statements, and so in the end we get AD over BC. So this is how I look at it right there. So in this expression right here, we have 7x divided by 2x minus 10 divided by x squared minus 6x divided by x squared minus 11x plus 30. So if I use this property up here, I get 7x divided by 2x minus 10, so I keep the first, change the sign, flip the second. So x squared minus 11x plus 30, and then I get x squared minus 6x. So this right here is the new expression that I'm going to be dealing with, and this is just multiplying, and we just talked about multiplying before, right? So multiplying before. So now I just need to factor, so I need to factor, this is already factored, so let's factor x squared minus 11x plus 30 if possible. So I need to find two numbers that multiply to be 15, or multiply to be 30, but add to be negative 11. So 30 would include 1 and 30, 2 and 15, 6 and 5, that's probably going to be it. So it would have to be x minus 6 and x minus 5. Alright, now let's factor 2x minus 10. So the only thing that they have in common is 2. So it would be 2 and x minus 5. And let's factor x squared minus 6x. I can factor out probably just an x, and I'd be left with x minus 6. So in this case, if I rewrite, I have 7 times by x over 2 times by x minus 5 times by x minus 6 times by x minus 5 over x times by x minus 6, and then now I can multiply, so I get 7x times by x minus 6 times by x minus 5 over 2 times by x minus 5 times by x minus 6. Now it's time to eliminate factors. So I have x minus 5, x minus 5, x minus 6, x minus 6, and then I have x and x. So I'm just going to be left with 7 divided by 2. Remember that I need to state my domain restrictions. So looking back here, none of these right here. So B, C, and D cannot equal 0. So anything that makes these three expressions equal to 0. So here, x cannot equal 5. So x cannot equal 5. In this expression right here, I think it would have to be, let's see. So what we could do is just do x squared minus 6x equal to 0. But this in factored form is x and then x minus 6. So then if this is equal to 0, x cannot equal 0 and x cannot equal 6. So x cannot equal 0 and x cannot equal 6. Okay? And then I think that covers everything, because this one would also be x cannot equal 6 and 5. So that already covers everything. Okay, so that would be our answer in simplest form. Alright, let's go over this one last example. So again, this isn't an expression, but we can make it an expression. And so it's dividing, so use the keep change flip rule. So I do 6x squared plus x minus 15 divided by 4x squared times by, so keep the first, change the sign, flip the second. So 1 divided by 3x squared plus 5x. And now I need to factor, so let's see what we can factor. So see if we can factor 6x squared plus x minus 15. Okay, so this one's going to be a little bit more challenging, because notice here that a does not equal 1. And so we need to find two numbers. So take a times by c, which is equal to 6 times by negative 15. Okay, so 6 times negative 15, that's going to be negative 90. Okay, so we need to find factors of negative 90 that multiply to be, that add to be 1. So factors that have to add to be 1. So they can't be really small. So I know 90 is divisible by 30. It's divisible by is it divisible by 5? It's divisible by 5, but that doesn't really get us anywhere. So 5 times by 18. 90, let's see if it's divisible by 6. So we can do 6 and 15. Still doesn't get us where, but there we go. So it's divisible by 10, so we can do 9 times by 10. Okay. So if it has to add to be positive 1, So that would have to be positive 10, negative 9. So negative 10. So in this case, again, where we have a factor that is, or we have a quadratic where a does not equal 1. So to do that, I'm going to take 6x squared, and then instead of writing x, I'm going to write it as positive 10x minus 9x minus 15. So by doing this, this right here is equal to positive x. So I'm not changing the value of the expression, just changing the way that it looks. And now I do what is called a factor by grouping. So here, look at the first two terms. What do they have in common? So I see that they have at least a 2 in common and an x. So let's factor out 2x. And I'll be left with 3x minus or plus 5. And then here I can factor out a negative because both terms are negative. And then I can factor out a 3. And I'll be left with 3x plus 5. And so now they have a common binomial factor. So here's the common binomial factor. And I can factor that out. So 3x plus 5. And when I factor that out, I'm going to be left with 2x and negative 3. So 2x minus 3. So that's this factored. Okay, now let's see if we can factor 3x squared plus 5x. And what they have in common is just an x. So then I'm going to be left with 3x plus 5. Okay, so now I'm going to come over here. I'm going to rewrite all these in factored form. So this one right here is going to be 3x plus 5 times by 2x minus 3 over 4 times by x squared. And this is being multiplied by 1 over 3 or times by this in factored form, which would be x times by 3x plus 5. So if we put them together, so just multiply across, I can cancel out these factors right here. And I think that's pretty much all you can factor, or that's all you can cancel. So I'll be left with 2x minus 3 on the numerator and 4x squared on the denominator. Okay, and then x cannot equal 0, and x cannot equal, so it would have to be, so whatever makes this equal to 0, so if I do 3x plus 5 set equal to 0 and solve for x, divide by 3, x is equal to negative 5 over 3. So that's what our domain restriction would be. So x cannot equal negative 5 over 3. Okay, that should do it for that one. Okay, so here are some extra practice problems I encourage you guys to work on to help you prep for your homework. But that should be everything for 6.3.